I'm thrilled we get to do this in the United States of America. I think this will be the most important project of this era, and as Masa said, for AGI to get built here.
Sam Altman recently shared his thoughts on what could be the most critical development for the future of U.S. infrastructure. This isn't just another statement. It's a bold claim with significant weight behind it, one that many people might not fully grasp. In this video, we'll unpack why his words are far from an exaggeration. We'll dive deep into the reasons that make this vision so impactful and explore the immense potential it holds. The focus of this discussion is Project Stargate, a groundbreaking initiative with a staggering investment of $100 billion, or perhaps even $500 billion. This project is poised to revolutionize AI infrastructure in the United States, led by OpenAI. Stay tuned as we break it all down and explore why this is such a game-changing moment. So, as you can see, they're discussing what is essentially the backbone of OpenAI's infrastructure in the United States. What's truly remarkable is that they're planning to invest $100 billion right off the bat. That's an absolutely staggering amount of money aimed at advancing future technologies. This kind of investment signals a major leap forward, and it's why I say this isn't just hype. Sure, there's a lot of buzz around AI right now, but when you dig into the real-world applications and potential, it becomes clear this is a game-changing moment in tech history. They also emphasize that this infrastructure is crucial for securing American leadership in AI. This is a really important point, and it's something many people don't fully realize. Behind the scenes, there's what you could call a silent war happening. And by that, I mean the competition between countries, particularly the US and China. Now, I wouldn't go as far as calling it an actual war, but there's definitely a race to dominate AI leadership. Many experts, including former OpenAI employees, have expressed concerns about this. One notable figure even left OpenAI, warning about the implications of AGI, artificial general intelligence. They suggested that whoever achieves AGI first could potentially wield unprecedented power over those who don't. That's a pretty intense statement, but it highlights the urgency of maintaining American dominance in this space. One way to ensure that leadership is by securing enough computational resources, or compute, to develop and operate advanced AI systems effectively. Reaching superintelligence first is the ultimate goal, and later in the video, I'll break down why such an enormous amount of money is needed for this, and why compute is currently the biggest bottleneck in advancing AI systems. They also mention that this initiative will create hundreds of thousands of jobs in the US and generate massive economic benefits globally. Beyond that, it's designed to drive the reindustrialization of the United States and strengthen national security for America and its allies. These claims are credible. By 2030 and beyond, much of the economy could be running on AI technologies. It might not feel that way right now, but many systems already rely on narrow neural networks that outperform humans in specific tasks. As this technology progresses, the economic and strategic benefits will become even more apparent. Projects like Stargate, essentially a network of enormous data centers, not just a single one, will likely be the backbone of this transformation. These data centers will support the growth and prosperity of America's economy, while other countries will likely develop similar initiatives to keep pace. What's really fascinating here is something Noam Brown, the lead on reasoning at OpenAI, mentioned. He said this is comparable to the Apollo program, that monumental achievement when humans first landed on the moon. It was a groundbreaking moment in space exploration. He also compared it to the Manhattan Project. If you've seen Oppenheimer, you know exactly what that was about. The top-secret World War II project where scientists raced to create the first nuclear bombs. That project was arguably the most intense scientific experiment in history. The goal back then was to achieve something groundbreaking before other countries could, knowing that whoever developed such technology first would hold immense power. Brown pointed out that this level of ambition, investment, and urgency feels similar to what's happening now in AI. He noted that projects like this, ones that consume such a large fraction of the GDP, only happen when the science is meticulously reviewed and there's confidence that the results will be transformative. And I completely agree. It's the perfect time for this. To those of you who are skeptical of AI, saying it's just a passing trend or that we're in some kind of AI bubble, there may be a sliver of truth to that. But let's not overlook the bigger picture. We're in the middle of what I'd call our 21st century project. This is something that's genuinely going to reshape the world. That might sound like an overstatement, but stick with me. I've got more to say, and we'll dive deeper into this as the video goes on. So, remember when I mentioned earlier that I made a video about this before? One of the key points I discussed back then was the fact that the biggest bottleneck for many of these companies is essentially compute power. At that time, there was a lot of uncertainty about whether these companies would actually move forward with such massive investments. But during that period, Sam Altman publicly stated that the primary hurdle slowing down progress in AI was the lack of enough servers to develop it further. You might be wondering why that's such a big deal. Let me explain by going back to the original research. The latest paradigm shift in AI development has brought significant improvements in raw reasoning capabilities. This advancement revolves around incorporating search and inference during the model's response time, or what's often called test time compute. Essentially, this allows the model to take a moment to think before answering. Previously, when you asked a question to models like ChatGPT, they would instantly generate a response based solely on the input you provided. While this was effective, it limited how smart the model could appear. Recently, researchers at OpenAI and other labs have made remarkable strides in this area. In fact, this concept wasn't entirely new. They began exploring it back in late 2022 and 2023. Now, they're actively applying techniques that enable AI models to pause and process information more thoughtfully before responding. There are various methods to implement this, and if you're curious about the technical details, I've covered them in a separate video. It's truly fascinating. But to sum it up, this innovation allows AI to think more effectively before providing answers. They can approach tasks in many different ways, all of which are incredibly efficient. Plus, since they have the ability to process information continuously, the longer they analyze or think, the better and more refined the results become. So, with these graphs, every time you've seen them, what you're essentially looking at is the increase in the capabilities of these systems as they're given more time to think. This is something most people don't really notice. The crazy part isn't just that these models improve, it's how they improve. When they ran search time inference on a range of really tough questions, the fascinating thing was that the accuracy didn't drop. Instead, as they applied more computational power and allowed the systems to search for solutions over longer periods, the results kept improving. Even more interesting? There were no signs of this improvement slowing down. Right now, the only real reason why AI systems haven't hit that massive explosion in capabilities is a lack of computational resources. They simply don't have enough processing power to let the AI think for extended periods. That's the main bottleneck preventing the development of potentially super-intelligent AI. Of course, there are other challenges to achieving super-intelligent AI or AGI, artificial general intelligence, like making AI autonomous and enabling it to handle certain tasks independently. But that graph showing test time accuracy really caught the attention of researchers. It's one of the reasons behind the controversy that led to Sam Altman's firing. Remember that big AI shakeup? Now, here's the key takeaway. The reason AI hasn't reached superhuman capabilities yet is mainly due to limited infrastructure. There aren't enough data centers to support the level of inference time these systems need. But once we build out those data centers, things are going to get wild. By then, we'll likely have more efficient search capabilities and significantly more computational power, maybe 10 to 20 times what we have now. At that point, the advancements in AI could be absolutely groundbreaking. Now, here's something most people don't realize. This project spans the next 6 years. It's not about building one massive supercomputer as some might think. Instead, it's a series of installations that companies are planning to roll out over time. So, no, it's not a single giant machine, despite what some Twitter posts might suggest. What they're really doing is setting up a network of massive, interconnected data centers. These centers will be the backbone for powering advanced AI systems. The urgency here is real. Companies are racing to get this done while they still can. Why? Because if another nation beats them to achieving superintelligence, it could have serious consequences for those who fall behind. This is why many experts believe that 2030 will be a pivotal year. By then, it's highly likely that these phases of supercomputer development will be complete, and the landscape of AI will look very different. Now, here's something really fascinating. If you look at this graph, and I know it might seem a bit confusing at first, it basically shows a series of models tested against a very challenging benchmark. This specific benchmark, known as the ARCAGI benchmark, has been considered one of the toughest out there. In fact, many people thought that cracking this benchmark might indicate OpenAI was getting close to achieving AGI, artificial general intelligence. Initially, we started with the 0.1 mini model, which scored around 7%. Then, the 0.1 preview version came in with a significant jump to 13.3%. What's happening here is pretty clear. As these models evolve, their performance keeps improving. For instance, you can see scores rising from 25% to 31%, and then to 32%. These increases are mainly due to advancements in compute power and model efficiency. Now, with more data centers coming online and even more resources being poured into this, could we potentially see scores hitting 99% on some benchmarks? Honestly, it seems quite possible. To give you an idea, with the highest compute power available at the time, they managed to hit 88% on this benchmark. This progress is a big reason why so many people are optimistic about the future of AI and what these technologies might achieve. One of the most fascinating moments we witnessed was a conversation between Sam Altman and the President of the United States. During their exchange, the President asked Sam to explain what this technology is capable of and why we're building it. Sam's response was bold. He said that AI has the potential to cure all diseases. Think about that for a moment. That's an incredibly profound statement. Curing every disease sounds almost impossible when you consider the sheer number of illnesses and their complexity. Some diseases don't even have basic solutions yet because there aren't enough cases to study or the mechanisms are too complex to understand. But here's where AI could truly revolutionize healthcare. With AI, you could simulate patients, predict reactions, and explore countless ways to approach these problems. The possibilities are limitless, and that's what makes building this technology so groundbreaking and important.
These guys can maybe share more about some of the work they're doing there. I think they'll jointly be some of the leaders about driving progress here. But I believe that as this technology progresses, we will see diseases get cured at an unprecedented rate. We will be amazed at how quickly we're curing this cancer and that one and heart disease, and what this will do for the ability to deliver very high quality healthcare, the costs, but really to cure the diseases at a rapid rate, I think will be among the most important things this technology does.